It is the 25th of February, 2019. I'm just going to hit make sure that the frame includes everything that I'm expecting it to. We are going to take apart and do a little bit of reverse engineering on this rock crawler called the Conqueror. It's a 2.4 gigahertz remote control truck, very inexpensive on Amazon right now. So we'll just start by turning it on and making sure everything functions. I did some work on this yesterday, and the video didn't turn out, and the audio didn't turn out. So I know a little bit of this stuff, but we're going to go through it all again. So just, it goes forward, it goes forward, goes reverse, it goes and turns to the right, turns to the left, and that's pretty much all it does. So I'll shut that off. I'm going to leave that in the picture. We'll shut this back off. I'm going to be checking out, making sure that the camera's getting this, because I have taken too many of these and had to redo them. Okay, so the frame is connected to the cover by these 4 screws, which I have loose. I'm just going to take them out. I'm going to pop the cover off. Okay, I'm going to get this box out of the way. So the way that it seems to work best is to pop the front off and then just lift. Comes off. I'm going to set that to the side. And then we're going to set this down, and the screws will mostly fall out. So we've got 1 in each corner. Now, I recommend that you take these 4 screws and put them into a little bag so that you don't lose them. This is something that I've seen on other videos, and it seems to work quite well. So here we have our circuit board. Such as it is, we've got 3 connectors. Steering, which goes to the front, and then we have the rear and the front motors. They are driven at the same time. They're in parallel. Doesn't matter if you get them mixed up. They are keyed, so you can only put them in one way. There's a little notch on one side. And we have the red to my left and the black to my right on those. And then the black is the furthest away from me, and the red is closest to me. If I was to get that wrong, all that would happen, it would go reverse instead of forward, or the other way around. We're just going to stand up and check. Yep, everything is still in view. So, actually, we'll bring this back a little bit. So there's 1 screw holding this down. So we will just take him out and add him to the plastic bag. So this is the way that the controller is set up. We'll just get a small pair of pliers and gently wiggle these connectors out. They're not probably rated for taking out and in as many times as I have, so I'm trying to be careful. I don't want to break anything. This plastic does seem to slide in and out. So that's the steering. And then we have motor and motor. So we'll get those out of the way, or as much out of the way as we can. Get a little bit of tape. It doesn't get in the way when we're looking at stuff. There. So I have gone ahead and got a little alligator clip. The alligator clip is going to connect to this where the wire, black wire from the battery is connected. We're going to change the voltage. I have also added an alligator clip to my awl, which is what I'm using as a probe because it is much sharper than the probe on my meter. So right now this shows you that it's 0.54 volts. Why do I have it on voltage? I should have had it set to ohms and showed you that it's that. Anyway, what we are going to do is name these chips. So this, I believe, is a driver chip. There are 16 pins on it. This is the notch, and that's pin 1. And then on the back, there's another driver chip, which is smaller. Get it turned around for you. That's this guy. He's got 8 pins. And then there's what I believe is the microprocessor, which has 1, 2, 3, 4, 5, 6, 7, 8, so it has 16 pins. So the general idea is we're going to go through and check which ones are connected to ground, which pins are directly connected to ground with the old meter here. Then we're going to check which ones, if we can get a good connection to positive, we're going to check which ones are connected to positive. And then we're going to turn on the power and check for voltage at various different places. Because this is my second time doing this, I know that there is 3.3 volt and 5 volt on the board. I believe all the 3.3 volt stuff is connected to the microprocessor, and all the 5 volt stuff is coming out of the drivers. We're just going to check that. So right now, we're going to start with pin 1 on the driver and check if any of them were connected to ground. So we're all the way up to pin 8. Turn it around a little bit. And check 9, 10. So pin 10 seems to be ground. 11. 14, 14, 15, so 10, oops, I've lost my alligator clip. Maybe it's not the best thing to have it hanging by the alligator clip. Let's see what I can do here. Up in 9, 10 is ground, 11 is ground, 12 is not, 13 is not, 14 is ground, 15 is ground, 16 is not. So that's on my driver chip. The reason that I got the sharper, I'm just going to sit this under here. The sharper probe is because my probe accidentally touched 2 of the pins at the same time on this guy several times. So I got pin 1, pin 2, pin 3, pin 4, pin 5, pin 6 appears to be ground, pin 7 appears to be ground, and pin 8. So that's the second driver chip, and right here is the marker for the microprocessor. So pin 1, pin 2 seems to be ground, pin 3, pin 4, pin 5, pin 6, pin 7, pin 8, pin 9, pin 10, 11, 12 seems to be ground, 13, 14, 15, and 16 seems to be ground. So, those are the connections, at least that appears to be the connections for ground. Now we're going to check this side of the board. There's nothing conductive up here. So as long as my gator gets across, then we'll have to pull this back a little bit. As long as the gator gets across and just touches there, not going to jump up and down and say that one. Yeah, I don't think that worked. Yeah, I'm going to have to hold that. That's going to be much more difficult. So I'm going to try my best to hold this there and then check everything else. So this is checking for 5 volts. Well, it sounded like it was there, but not quite. Yeesh. Well, I tried to make the tools a little bit easier to use, but it hasn't worked real well. 5 volts. Okay. Well, let's try pin number 1. 2, 3, 4. Pin 4 seems to be 5 volts. Pin 5, 6, 7, 8. Again seems to be 5 volts. 9, 10, 11, 12, 13, 14. 14, if you remember, was also connected to 0 volts. That's weird. 15 is 5 volts. And 16. So I'm a little bit confused about that. Let's just make sure that's a good connection. And we'll start at pin 1 on the little guy here. Driver, 1, 2, 3, 4. Pin 4 seems to be 5 volts. 5, 6, 7, and 8. So the only connection I see is pin 4. On the, what I think is the micro, we're going to go with 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I do not see a connection to 5 volts on this guy, which would make sense since I think it is a 3.3 volt chip. I would expect 5 volts to go through a regulator or a DC to DC converter. So that's it for the power off checking. So we will get our negative probe connected back to the gator, which is connected back to here. We're going to turn on the power. I'm showing voltage. Let's see whether the camera is still showing voltage. It is. Okay. So I'm going to stick this underneath here so that it doesn't weigh anything down. And right now we've got 4.983 volts. So we're going to turn on our remote And then we're going to go through basically the same check. I might not do the micro, but we're going to go through the chip. We're going to go through these, which look to be floating. I would expect to be floating because there's no signal. So I'm going to start with pin 1 is 3.3. Pin 2 is 0. Pin 3 is 0. Pin 4 is 4.97. I'm going to call 5. Pin 5, 3.3. Pin 6 is 0. Pin 7 is 0. And pin 8 is 5. Pin 9, I have to be left-handed here. Pin 9 is, well, a few millivolts. I'm going to call it 0 plus. Pin 10, 0. Pin 11, 0. 12, 0. Actually slightly negative. 13, again slightly negative. 14 is 0. 15 is 0. 16 is slightly negative. So that is the signals when there is no command coming from the remote. And then we're going to go through the signals on this driver as well. I've got to get a little closer because I am not seeing so well, and these are not trifocals. So try and keep my head out of the way here. Pin 1, 3.3. Pin 2 is 0. Pin 3 is 0. Pin 4 is 5 volts. Pin 5 is floating. Pin 6 is 0. Pin 7 is 0. And pin 8 is floating. Okay, on the micro. Pin 1, 0. Pin 2, 0. 3, 3.1. Pin 4, 0. Pin 5 is 3.3. Pin 6 is 0. Pin 7 is 0. Pin 8 is 0. Pin 9, 0. 10, 0. 11 is 0. 12 is 0. 13 is 1 volt. 14 is 1 volt. 15 is 2.1 volts. 16 is 0 volts. So that's where we are when there is no signal at all. So I am going to take some wire and jam the trigger in the forward direction. As you can see, the little light is on, so we are asking for forward all the time. So first thing we're going to do is check the, okay, so we go this way, so the pin that is forward is 0. The pin that is to the back is 4.9, which is 5 volts. And same thing on these two. We are not expecting anything on the steering, and they look to be both floating. This is expected. And I'm just going to go through the terminal, the connections again. So 1 is 3.3, 2 is 0, 3 is 3.2, 4.9 is 4, 5 is 3, 3. 6 is 0. 7 is 3, 2. 8 is 5. I told you I was going to call that 5. 9 is 5. 10 is 0. 11 is 0. 12 is 0. 13 is 5. 14 is 0. 15 is 0. And 16 is 0. Now, I have already checked that all of the signals on this driver have not changed, but to be complete, because I do make mistakes like everyone else, we will check. Pin 1, 3, 3. Pin 2 is 0. Pin 3 is 0. Pin 4 is 5. Pin 5 is floating. Pin 6 is floating. Pin 7 is 8. 0.8, sorry. Pin 7 is 0. And pin 8 is floating 0.2 volts. Okay, now for the interesting part, we're going to do the micro. Pin 1 is 0. 2 is 0. 3 is 3.1. 4 is 0. 5 is 3, 3. 6 is 0. 7 is 0. 8 is 0. Oh, my signal seems to be, I just noticed that the little light went off. So we're going to make it a little tighter. Which, I don't know if any of the signals that I did were wrong, but we'll try. 9 is 0, 10 is 0, 11 is 3.2, 12 is 0, 13 is 1.1, 14 is 1.1, 15, oops, I counted wrong. 9 is 0, 10 is 0, 11 is 3.2, 12 is 0, 13 is 1.1, 14 is 1.1, 15 is 2.1, and 16 is 0. Okay. We will take the wire off for going in reverse. We're now going to go in forward. So you can see that it's in forward. And we're going to check everything again. So the pin that is to the forward is now 5 volts, and to reverse is now 0 volts. And we are still floating with both signals on the steering. We're going to start with pin 1 on the driver is 3, 3. Pin 2 is 3, 2. Pin 3 is 0. Pin 4 is 5. Pin 5 is 3, 3. Pin 6, 3, 2. Pin 7 is 0. Pin 8 is 5. Pin 9 is 0. Pin 10 is 0. 11 is 0. 12 is 5. 13 is 0. 14 is 0. 15 is 0. And 16 is 5. I'm not going to go through the small driver chip again because nothing changed. Now we're going to go to the micro, which is the interesting part. So pin 1 is 0. Pin 2, I should change my position. Pin 2 is 0. 3 is 3.1. 4 is 0. 5 is 3.3. 6 is 0. 7 is 0. 8 is 0. 9 is 0. 10 is 3.3. 11 is 0. 12 is 0. 13 is 1.1. 14 is 1.04. 15 is 2.1. And 16 is 0. Okay. We're going to stop going forward. So we are going to take the next thing is we're going to take some tape and lock the remote into what should be turned to the right, I believe. So turn to the right, we've just forced that forward, or clockwise, I guess, if you like. And we're going to, well, first of all, we're going to check everything's still in view. I guess I should show that way. So you can see the little light's still on. So, starting on top, we have 0, front is 0.1, so front and back are floating. And then on the right left, I guess the one furthest away from me is 0, and the one nearest me is 5 volts. I don't remember whether that was red or black. Going through the driver, which I don't believe has changed, we're going to go 1, 3, 3, 2 is 0, 3 is 0, 4 is 5, 5 is 3, 3, 6 is 0, 7 is 0, 8 is 5, 9 is 0, 10 is 0, 11 0, 12 is a few millivolts, 13 is a few millivolts, 14 is 0, 15 is 0, and 16 is a few millivolts. The one that makes a difference on this one is the little driver chip, which we are going to put some reading glasses on so I can focus a little bit. And we're going to start with 3, 3 on pin 1, 0 on pin 2, 3, 2, or almost 3, 3 on pin 3, 5 on pin 4, pin 5 is 5, pin 6 is 0, pin 7 is 0, and pin 8 is 0. So if you follow the traces from the right left, you are expecting it to come from pin 5, which is 5 volts, and from pin 4, which is 5 volts. I don't think that's right. Anyway, those are the values. On the micro, I gotta change my position here. 0 for pin 1, 0 for pin 2, 3 for pin 3, I guess 3.2 for pin 4, 3.3 for pin 5, 0 for pin 6, 0 for pin 7, 0 for pin 8, 0 for pin 9, 0 for 10, 0 for 11, 0 for 12, 1.1 for 13, 1.1 for 14, 2.1 for 15, and 0 for 16. Okay. We will now change from having the direction that way to having the direction the other way. And we will go through it one more time. Oh, tape came off. Okay. There we go. And we have the probe cable has moved for me. Time to check whether we're still, okay, I don't know how much of that I lost because the stupid camera went to 30 minutes and stopped. Okay, we are now recording again. I guess we'll see how much we lost. Okay, so in this position, the nearest to us is 0 volts and the furthest away is 5 volts. I'm not going to check this one because I know it doesn't change. I entered the numbers into a spreadsheet yesterday. Now we're going to check the little driver. So pin 1 is 3.3, pin 2 is 3.2, pin 3 is 0, pin 4 is 5, pin 5, 0, 6, 0, pin 7, 0, and pin 8 is 5. Now on the micro, we got to change a position. Pin 1 is 0, 2 is 0, 3 is 3.1, 4 is 0, 5 is 3.3, 6 is 0, 0, 8 is 0, 9 is 3.2, 10 is 0, 11 is 0, 12 is 0, 13 is 1.1, 14 is 1.1, 15 is 2.1, and 16 is 0. So, there we go. That about does it. So I will tabulate all of this and put it in the description. I'll put a link to it in the description anyway. This guy goes this way. We'll take that off for the remote. And we will put the screws back in. Little guy goes in here. Oh, I guess I should shut the power off first. I could put it to get back together with the power on, but it doesn't make any sense to. Put the screw into the hole and then let it go through and have it and hunt for the screw location. Do a little check to make sure none of the wires are pinched. Curl that in there. That used to come underneath there. We'll stick her under. Make sure that it's not touching anything else. Okay, take off the wires for here. Coming through there, and connect. And then come through here. And then connect. Okay. I pin the pins. No, it doesn't look like it. Yeah. Goes in. And not sure what I'm avoiding here, so I'm just going to put it down like that. Come through here. I'm just going to kind of curl around. And get them put back in. Okay. All right. Shut this guy off. Get some probes out of the way. Set this back up. So, the way that I've been doing this is get a small pair of pliers, grab the little screw, and set her in. So while I'm doing this assembly, we're looking to hijack the signals between the microprocessor, which is decoding the radio signals for us, and the drivers, which take the 3.3 volt signal and drive the motors with 5 volt and much more current than the Arduino can. So to do this, we would cut the 4 or 6 or maybe 7 signals from the microprocessor to the drivers, bring those signals into the Arduino, do whatever logic on them that we are wanting to, and put out those 3.3 volt signals to the driver chips. So we'll have to use a voltage divider, with either on or off signal like they are now, or a PWM signal to run the motors at reduced speed. I can use the 2 LEDs on the Arduino board to show when I get different inputs and when I get different outputs. So again, to get this put back together again, kind of get the back in first. Here. Okay. Yeah. That probably didn't help any of you, but these are in. Put them in just with the catch. So you can see that they're in because they're closer. These ones are out. You can see that they squeeze in like this. And I don't know whether I've got a cable pinched or the story is. Okay. Now, I'm going to check that this stupid camera is still recording. It is. We will turn the power on, flip it over, put it back on my spacer, turn this on, and then so I haven't broken anything, or at least it still appears to work. And that is it for today. I've got to type in a bunch of pin settings into a spreadsheet and see how much video I missed when the camera hit 30 minutes.